Okay, good afternoon, everybody. I'm Mingzhi Christensen from IBM OpenPOWER. First of all, this is a beautiful place to have a conference, and great job, Sydney. And I would like to introduce myself briefly before I go into the presentation. I spent about first 12 years of my career at IBM design power and mainframe microprocessors. And over the last few years, I see in order to embrace the industry challenges, I need to go beyond microprocessors. So I joined the IBM OpenPOWER team. And for the last few years, I've been working with thought leaders of the industry and figure out how we can build systems together to bring the best cost performance for your customers. So in this presentation, I will talk about what OpenPOWER is, why OpenPOWER, what we have accomplished over the last few years, and also what's next in the AI and also cognitive system, and also how you can participate. Now, first of all, let's look at the challenges that we're facing. We all know right now it's becoming a mainstream thought that Moore's law can no longer provide the efficiency that is the need for the industry. Rely on semiconductor alone, you can no longer get the next generation of cost performance that the technology partners and customers have been used to. So microprocessors alone cannot provide sufficient price performance for your customers, so multiple innovation are needed across the entire stack. And that's why so that's one reason. In fact, from a power performance perspective, the innovation has begun over the last few years. For example, virtualization, advanced memory and I/O systems. These are the things why we have been doing to try to stay on the Moore's law trajectory. And now we just need more of it because, as you can see on the right-hand side, we're going through a data explosion. Based on IDC information, by 2020, the world will reach 44 zettabytes of data, and most of them are unstructured. And zettabytes, that's 21 zeros. So this is very much looking for insights they can get out of these unstructured data. We also see, we talk about the technology challenges. We also see the market is shifting. First, we talk about the limitations of Moore's law. And also we're seeing rapid development of various workload, in particular in the big data, data analytics, and also AI algorithms and AI software. So these are the areas we're seeing industry is shifting so rapidly. In addition, we're seeing the IT consumption models is changing as well. For example, people can get pay-as-you-go cloud, or you can use cloud by signing enterprise agreement. Also, more and more hyperscale data centers are either building their own systems or buying directly from the ODMs. And the last reason we see is software. Open software are becoming more and more mature, and they become good enough for enterprise to become very interested. And we can see the customers very much resistive to closed proprietary software. In fact, there are probably many programmers in the audience. Who doesn't want your code to be used by your peer and shifting and driving the industry? So these four reasons alone, together we decided we need to create an open innovation model called OpenPOWER. So a few years ago, IBM, Mellanox, NVIDIA, and Google formed OpenPOWER Foundation. This is our answer to drive the open innovation. And to drive them, first of all, we see it has to be open. In fact, we not only just opened up on the system and the software level, we actually opened up the power architecture. Our goal is to give our customers and partners more access to have more meaningful and deeper innovations and also collaborations. In addition, we see customers no longer want just 10% of performance improvement. They want to have 10x of performance improvement. How do you deliver that? That's why we invite thought leaders across industry so we can work on cost performance and price performance together. In addition, what we're seeing, what customer wants, they're looking for a few things. They want to have choices. They want to have choice to differentiate. They want to have choice to innovate. They want to have choice to grow. By being part of the OpenPOWER Foundation, you can leverage the basic power building blocks. And you don't have to use one-size-fits-all components. You can actually choose the best of the breed components from OpenPOWER Partners, and then customize your solutions, either hardware and or software solutions, towards your industry and your customers. And in the end, what you have is you not only innovate within your own company or with IBM, but also you go beyond to innovate with a bunch of partners that are leading the industry. And so that you have a chance to grow, either grow deeper in your industry, in your market space, or tap into your adjacent market space. Now, for OpenPOWER, how do we do it? As I said earlier, first of all, it's built based on power architecture. And that's what we're going to have our architect next to talk about more around our power architecture and the accelerations around it. And second, we opened up the architecture to invite thought leaders to have more meaningful collaboration. And therefore, we have a vibrant ecosystem that drives the innovation. And that's how we get the performance amplification. Our goal is to give your partners to collaborate together and deliver partners and your customers of a 2x, 3x, and 10x of performance amplification. When you think about OpenPOWER, probably a few things came in mind. For example, CAPI, reference design, open back to the foundation. Also licensing power architecture, and also various work group activities. These are the things you can think of as a truly, truly open. Now, over the last few years, this is what a growth looks like. We have more than 300 of OpenPOWER partners. In fact, this number changes on a daily basis. And we have presence in 31 countries and also 6 continents. We have more than 20 system partners, system manufacturers, and 40 ISVs. The software area, this is where we started shifting our focus from hardware in addition to software and applications. And as of now, we have more than 100 OpenPOWER ready systems. We have a work group. Instead of everything goes through IBM, go through Power, which we have limited resources, you can take this specs and test it yourself and bring the results to us and certify your products as OpenPOWER ready. In addition, we'll have 40 OpenPOWER systems shipping, and 60 of them were actually revealed in the OpenPOWER Summit last April in California. So this is, as you can see, we have innovations across the entire stack, from chip all the way to applications and HPC. And T2I is definitely up here. Across the board, we actually see about 70 plus OpenPOWER members in Europe, a lot of them in the SI space, software space, and also HPC. In addition, one essential is a cross-organization collaboration. That's why I'm here collaborating with HPC Advisory Council and also OCP, so we can define specs together and define best practices together, and also opened up the reference design and contribute back to the community. Now, what difference does it make? We've been around for a few years. First of all, let me start with a brief history lesson. We started in 2013, 2014, and we set up the vision, built the partnerships, and set up the bylaw and IPR policies. So very much setting up the stage at the beginning. Then 2015 is a year of development. OpenPOWER Partners heads down, started to build tons of systems. And 2016 is the year of deployment. Some critical systems have GA'd last year. And also, many of them were seeking for market acceptance and adaptation. And that's why in last year's OpenPOWER Summit, there were 60 hardware all the way through software solutions were presented at the summit. There are 3 markets we're focusing on. Hyperscale and the cloud service providers is one market, high-performance computing, and also domestic IT agenda. This chart I'll briefly skip. These highlight some of the key milestones we have over the years, and these ones in red circles are the HPC ones. Now let's look at our acceleration roadmap. First of all, to be able to be successful in a scale-out environment must have a great network and a fabric. That's why Mellanox is one of our strategic partnerships. Their roadmap is nicely aligned with Power roadmaps, from Power 8 to Power 8 NVLink to Power 9. In addition, Power processors, starting Power 8, is the only microprocessor have 2 acceleration buses, high-speed accelerating buses. The first one is PCIe and CAPI. We built across the generation, which Jeff will discuss more in his presentation, and we'll have alignment with FPGA partners such as Xilinx. Also on MVLink, this is something I will discuss a little bit more in depth in this presentation. We'll have alignment with NVIDIA, so you can get that GPU to CPU speed up and also bandwidth gain as well. Now, specifically, let's talk about NVLink. As you can see, PCIe Connect GPU to CPU only delivers 32 gigabytes per second of speed. That's very much, despite you may have the newest generation of NVIDIA Pascal P100, but you're limited by the PCIe bus. And that's why we work with NVIDIA to develop the NVLink. First, you will see speed up. You went from 32 to 80 gigabytes per second. That's 2.5x of speed up. And in addition, you have a balanced design. In the system of Microsoft microprocessor world, balanced design, as you all know, is very, very important because there's always that bottleneck. We're trying to make sure all the lanes of highways are wide open. In addition, in the HPC world, especially in science and research, you probably worry about 2 things. Either you're already running out of GPU memory, or you're worried about you're going to run out of memory soon. So by having the NVLink, what you get is GPU now can map into system memory. Each CPU, Power 8 NVLink CPU, has about up to half a terabyte of system memory. Now you have 2 of them altogether, you have 1 terabyte of system memory that your GPUs can have access to. So you're not only getting the speed latency gain, but also the bandwidth gain. That's about 5x of the bandwidth gain. From the HPC perspective, we certainly see in this area there is actually more data sets, bigger data, more data sets, and also larger models. So NVLink is the premier system to help you solve all these challenging and real-life problems. Now on the CAPI side, I'll skip all the technical talks, but from a partnership perspective, we have about a dozen partners working on CAPI and OpenCAPI. That's IBM Mellanox, Bitware, Xilinx, and also we have Nelatech and Alpha Data have the acceleration cards with Xilinx FPGA. From there, we're going to build even more the memory and the storage. In addition, one thing I want to add to the chart is CAPI Snap. That was revealed last October in OpenPOWER Summit in Spain, in Europe. So from basically we see our software programmers are really, really smart. They can write great high-level programming language, but there is a gap from there to low-level machine language to VHDL Verilog. That's what the Snap framework is for, so that you don't have to worry about that translation, that framework translate that for you. And also, we talk about NVLink will be great for deep learning and also training. We see, in my opinion, I see CAPI and OpenCAPI give a very much a cost-effective and power-efficient way for inferencing applications. Now, let's talk about the results. First of all, in China, we see, well, first of all, in the hyperscale data center side, we see Google and Rackspace very much collaborate with IBM and Ingresys, which is the ODM, developing Power 8 and now they're developing Power 9 systems. In fact, they're open. If you were to go to Open Compute website, look for Zayas and Barrel IG2, you will see specs and all the information about that system on the website, completely open. We contribute back to the organization. Also, you see the Inspur built their own 2-socket OpenPOWER server, and also the microprocessor chip called CP1 in China. In particular, Tencent is the #1 or the largest cloud provider in the world. They actually broke 4 sort record in minute sort and grid sort last year. With collaboration from IBM, Mellanox, and also Supermicro, we built the system, tuned them, and helped them enable to have 2.8x to 5x of a performance speed up than 2015 winners, and 30+ x of speed up per node performance than 2015 winners. Now on the HPC side, there are a lot of development on the HPC side. From a market perspective, we're sitting $12 billion of HPC market. That's just the HPC hardware alone. And in addition, we have hundreds of HPC softwares running on Power. 8 out of 10 top HPC applications are on Power, and Ansys Fluent will be available on Power mid-year. In terms of enablement centers, we have them. We have 4 different types of enablement centers from IBM and also from partnership with Mellanox and NVIDIA across the world. So if you want to have a jump start on it, talk to me, talk to your salespeople, should have no problem and get you on one of the acceleration centers. Let's talk about the win cases. As you all know, we have the US government DOE win, and we will deliver this year. Expect to see 5 to 10x of application improvement compared with previous generation. And also GenC for science application, scientific application, and also Hartridge, UK Hartridge, for their big data and analytics. So these are the win stories from the major national labs in the US and also Europe. On the university side, for example, University of Michigan, Virginia Tech, those are the areas we see they're very interested in HPC clusters, deep learning, and also AI. In particular, University of Michigan, you have actually very broad workload. Real life applications from cardiovascular analysis to material science to climate simulations all the way to galaxy simulations. So they deployed, all these are combination of partnership with IBM, NVIDIA, and Mellanox. That Mingzhi system very much opened the door for us. And also we're doing human brain research, and also we're helped to work on various GPU hackathons. Due to time limit, I'm gonna skip much about that. So let's jump to Power AI. As you know, we have this awesome hardware of Mingzhi. Now, what do we go from above that? Of course, it's on the software. That's what we have. We built a Power AI framework. Think of it as it is the Red Hat for deep learning, because that's where the market is going. Based on IDC data again, we expect to see $47 billion of AI cognitive market opportunities. And that's a combination of hardware, software, and services. And we're sitting at $15 billion right now. Just from hardware alone, we expect to see $6.8 billion of hardware opportunities by 2020, and we're at about 1.7 right now. So with this huge market, we built this Power AI framework. The goal is decrease the deployment time. Instead of spending time, figure out where your drivers, the kernels, all the setup, hunting in the internet, you can install the package for free if it's on a Power system. And in addition, give you the deployment time is decreased to 45 minutes from weeks. So you can get to the meat of it to develop software algorithm and applications. We talked about the hardware already. It's built based on Mingzhi hardware. And now on the software side, we have the top deep learning frameworks are in Power AI, and more will be added sometime this year. For example, TensorFlow, Caffe, Torch, Theano, Chainer. As we're speaking, there are more in the work. The critical ones you probably already know. We're thinking about how to get them poured on Power, have leadership performance. Now, let's quickly talk about the performance gain, as this is out of box between Mingzhi and the x86 and the previous generation, because at the time, there's only previous generation of GPU available. We're seeing 2.2x of a performance improvement. Now, get a more fair comparison that x86 with the current Pascal GPU P100 and then compare with Mingzhi, we see easily 30%. That's just out of the box. And if you were to tune it, again, you can actually see 2.2x or more of improvement. How do you get started? As I said earlier, if you already have a Mingzhi system, download Power AI for free. The binaries are available. And also, we upgrade them on a quarterly basis. If you don't have it, there's an easy way to get it started, is through the Nimbix Cloud. Nimbix is an HPC cloud company in Dallas, Texas. They have a fleet of Mingzhi systems. And in addition, they not only provide hardware as a service or infrastructure as a service, but also if you want to tap into Kinetica, they also provide software as a service as well. So you can, if you truly have AI projects, deep learning projects, you can contact me or contact your local salespeople. They know how to reach out to me, so we can get you some either 30 days, 30 hours, or 30 days, 60 hours of free access to Nimbix Cloud. Now, I think since we have limited time, I'm gonna skip the how to join, because all this information you have, you can easily find at the OpenPOWER Foundation website. And importantly, we want to continue to drive this open innovation model. We want to bring state-of-art microprocessor silicon to you, to your workload, to your software applications, so that you can get that 2x, 3x, 5x, 10x of cost performance gain. And in addition, OpenPOWER very much built on acceleration. We would like to arm your data center labs with accelerations on compute, storage, and network with CAPI, OpenCAPI, and also MVLink. Last but not least is next era is about deep learning and AI and cognitive computing. We want our IBM research is very much committed to bring that special IP to you, and also so that you can excel in this cognitive era. Thank you very much.